This is Mercury-Redstone 1, MR1, ready for launch at Cape Canaveral, Florida. Launch Complex number 5. The spacecraft is a production line version. This spacecraft is destined to make a successful flight over a ballistic flight path. It will not carry man, but will help pave the way for man in space. Mercury spacecraft are produced at the St. Louis plant of the McDonnell Aircraft Corporation. Hundreds of subcontractors, suppliers, and vendors furnish components and subsystems for this complex space-age vehicle. Development time in Mercury has been compressed by simultaneous research, development, engineering, manufacturing, training, and test. The first production Mercury spacecraft was flight tested less than 18 months after initiation of the program. At the Marshall Space Flight Center in Huntsville, Alabama, Redstone boosters are modified and tested. The MR1 booster was fabricated here. The Redstone booster modifications include elongation of the tank section to increase fuel capacity, engine and control system simplification, a mission abort system, and an adapter section to house control equipment. A special electronic brain is installed to sense possible trouble in time to permit the spacecraft and the astronaut to escape. All parts and components for Mercury-Redstone boosters are inspected and tagged when approved. Every possible precaution is taken to ensure reliability. At the McDonnell plant, Mercury spacecraft are assembled in a super clean white room. Here, every effort is made to make the craft as reliable as humanly possible. Cleanliness approaches hospital operating room standards. Every individual component going into the craft is minutely inspected. The electronic systems in the craft require some 7 miles of wiring. Special harness boards are used to assemble the growing mass of wire. Assemble it by hand, then check your work. Onboard systems for NR1 must be wired properly, then set to operate automatically, for there will be no human pilot on this flight to correct malfunctions. Attach sensors at key points to tell you how the craft performs in flight. Data measurements from 90 points and telemetry transmitters to send back information in flight. Structural heating and stresses, cabin temperature, pressures, noise, vibration, Gs. The airframe grows with its double-walled afterbody with insulating material between the walls. The heat-resistant shingles are in place. It begins to look more like a Mercury spacecraft now. Add components, then check your work again. Every subsystem is tested and retested to make sure it operates properly. Combine subsystems and test them again. Record your data. Then complete systems test. Make certain that all of your instrumentation and control and recording equipment are in the proper place. The instrument panel is installed. All interior equipment must be secured for the jarring flight into space. The MR1 spacecraft is complete. It measures 6 feet across its base and stands 9 feet high. With its escape tower in place, the overall length is 24½ feet. The completed MR1 spacecraft was airlifted to the Marshall Space Flight Center, where it received extensive compatibility tests with the MR1 booster. In addition to the electrical and mechanical checks, a long series of tests was performed to preclude the possibility of radio frequency interference between the spacecraft and the booster systems. In addition, the booster spacecraft combination underwent a simulated countdown, launch, and flight, using the same checkout and firing panels used at Cape Canaveral for the actual launch. The Redstone booster for MR1 was fitted with a test version of the spacecraft and static tested. Each booster is static fired before shipment to Cape Canaveral. When the spacecraft arrived at Cape Canaveral, it is sent directly to Hangar S. It had been checked and tested again and again, first at McDonnell, then at Huntsville. But the pyramid of testing had just begun. Immediately after arrival, it rolls into Hangar S. Inspect its heat-resistant outer skin to be sure it has not been damaged in moving. Check your inspection with a prepared checklist. Then move to Hangar S's White Room, where every system is rechecked to make sure that nothing has gone wrong inside during shipment. Reliability in Project Mercury is a must. Before the craft can be mated with its booster, it must be right. The MR1 booster is delivered to the launch pad. Mercury-Redstone is 83 feet tall, including the spacecraft assembly, 14 feet taller than the regular Redstone. The body of the rocket is 70 inches in diameter. Liftoff weight, including the 1-ton spacecraft, is 66,000 pounds. Using alcohol and liquid oxygen, the engine delivers 78,000 pounds of thrust. The additional fuel gained by elongating the fuel tanks increases the burning time by about 20 seconds. The spacecraft arrives at the launch pad. Time now for booster and spacecraft to be mated. Mercury-Redstone 1. After mating, the pyramid of testing continues. All the subsystems, all the systems must now fit together like a hand in a glove and function perfectly. The Mercury-Redstone program has two objectives: qualify the spacecraft in the space environment and provide training for the astronauts. On November 7, 1960, the MR1 countdown for launch progressed for more than 12 hours. During the last 4 hours, concern mounted over apparent pressure leakage from the attitude control systems. Less than 1/2 hour before launch, the mission was scrubbed. Before launch could be rescheduled, the attitude control system had to be repaired and a complete checkout performed on the booster and the spacecraft. On November 21, 1960, MR1 was again scheduled for launch and the countdown began. Everything proceeded normally, and all checks forecasted a successful launch. The repaired attitude control system on the spacecraft checked out perfectly. Weather was good all the way down the Atlantic range. Tracking and telemetry equipment were completely operational and ready to go. The recovery forces were deployed in the prescribed landing area, ready to pick up the spacecraft. The countdown neared 0. The Redstone engine fired, then shut down almost immediately. The escape tower fired. The antenna canister lid opened, the drogue chute popped, followed by the main chute, and then the reserve parachute. When the spacecraft received the engine shutdown signal, it began to do exactly what it was supposed to do. In response to the signals received, the craft functioned properly. Both the escape rocket and the parachute recovery system went through the normal sequence of action. A careful examination of telemetry data and the booster itself showed the premature engine shutdown to be caused by a relatively simple fault in a piece of ground support equipment. During the launch attempt, the booster was damaged. It was removed from the pad and shipped back to the Marshall Spaceflight Center to be repaired. Within a few days, a new Redstone booster arrived at Cape Canaveral. The booster received a complete pre-launch checkout and was okayed for mating with the spacecraft. The spacecraft is the same one used in the earlier launch attempt. It appeared to be undamaged, but of course had to be rechecked to make certain all systems would still operate properly. They checked out. Also, since many of the systems had been activated in the launch attempt, expendable parts had to be replaced. The MR1 spacecraft had several specific objectives. First, investigate the compatibility of the booster spacecraft combination during a flight designed to give a maximum acceleration of 6G, a period of weightlessness of approximately 5 minutes, and re-entry decelerations of 11G. Second, qualify the posigrade rockets that separate the spacecraft from the booster. Third, qualify the recovery system. Last, qualify the launch, tracking, and recovery phases of the operation. On the night before the launch, MR1 received its final checks and the countdown began. December 19, MR1 is ready to go again. The countdown proceeded normally with only one short delay. The recovery forces are in place, ready to pick up the spacecraft. In the Project Mercury Control Center, flight control personnel are ready for launch. This is the nerve center for the mission. Once MR1 is launched, they will take over until the craft is recovered. Downrange, the landing area is well covered. In addition, other elements of the recovery forces are deployed along the entire flight path in case something goes wrong. Launch is only seconds away. The flight control director is ready to take over. Radar and telemetry equipment is ready. This is another test in the pyramid of testing, flight test, another step toward man in space. After a perfect launch, MR1 followed a normal flight test profile. The spacecraft, weighing about 1 ton, follows a ballistic arc, peaking at approximately 130-mile altitude and landing 235 statute miles downrange. The complete flight takes 16 minutes and provides a little over 5 minutes of weightlessness, or 0G. At booster burnout, the cone-shaped spacecraft is traveling a little over 4,000 miles an hour. Panel indicators in the Mercury Control Center record each major phase of the flight as it happens. As the accelerating vehicle passes through the contrail level of the upper atmosphere, it etches a bright white trail to mark its progress. At about 140 seconds after liftoff, and at an altitude of about 35 miles, the booster engine is shut down and the escape tower is jettisoned. Here, on a condensed timescale, are the events which occur in flight, in space. Fire the posigrade rockets to separate the capsule from the booster. Set up the retro firing attitude. Fire the 3 retro rockets. Then jettison the retro rocket packet and retract the periscope. As the spacecraft encounters more dense atmosphere, landing and recovery sequence begins. Deploy the drogue parachute. Then jettison the antenna fairing to automatically deploy the main parachute. Until landing, then get rid of it to avoid dragging in the wind, and all on an automatic basis. Within minutes after landing, the spacecraft was picked up by helicopter and was on its way back to the primary recovery vessel just a few miles away. Radar chaff, dispersed at 10,000 feet as the main chute was deployed, provided a radar target. The underwater SOFAR bomb gave an audible landing point indication. The radio beacon was received loud and clear in the search aircraft. Sea marker dye helped the helicopters sight the craft in the water. The MR1 flight test objectives were all accomplished. Other, increasingly complex flight tests will follow. Back at Cape Canaveral, Mercury Project Director Robert R. Gilruth gets the first post-flight look inside the craft and looks well pleased at the successful results of the MR1 flight test.